object that's coming near Earth, its mass is 2 times 10 to the third kilograms, and its velocity is 4.5 times 10 to the third. In the x, in the y, it's negative 2.1 times 10 to the fifth, and in the z, it's 0 meters per second. And that's all at the position of 9 times 10 to the seventh, comma 6 times 10 to the eighth, comma 0 in the x, y, and z in meters. And that's all if Earth is considered the origin. Now we're trying to find the second momentum. The second momentum is found using this equation over here, which is the second momentum equals the first momentum plus the net force, which is going to be the gravitational force in this case, times the change in time. Now the first thing you're going to want to do is you're going to want to have to find the components to find the gravitational force. What you're going to need is you're going to need the magnitude of the vector r, which is where your position is. Now, after you plug in the numbers to try to find that by using this equation and such, and you're also going to want to have the actual value of r hat, then you go ahead and you plug them in. You find out that r hat is this, and that the magnitude of r is that here in the bottom, which you're going to use later. Then you're going to plug them all in. Now the equation is the gravitational constant times the mass of the smaller object and the mass of the bigger object times r hat times the magnitude of r, right there, r squared. After you plug those in, which is your gravitational constant, your smaller mass, your Earth's mass, your r hat, and also the magnitude of your vector r squared, then you're going to end up getting this number over here, which is, a 3 component, and that's your x, y, and your z, and that's your gravitational force. Now that you have your gravitational force, you also know that you have your change in time, because it said that it was 2.5 times 10 to the third seconds later, so that's your time. And also your first momentum, of course you go back here and you see that momentum equals mass times velocity. Well, the mass is always going to be 2,000 kilograms for the object, and the velocity at the given point in the beginning was 4.5 times 10 to the third, comma negative 2.1 times 10 to the fifth, comma 0 meters per second. So here's basically your first momentum, which is worked out right here, and then added with the gravitational force times the change in time. After going ahead and simplifying down a bit, of course you get kilograms meters per second on both sides, as you should for momentum. You have your P1, and then you have your gravitational force times the change in time, which is this over here. And now that you have that, you can add those together and you will get your overall second momentum, your final momentum that you were trying to look for. And of course it is 6.009 times 10 to the ninth, and the x component approximately 5.51 times 10 to the ninth in the y component approximately, and 0 in the z component, and that's kilograms times meters per second. And that is all. Thank you.